In this video, we'll be talking a bit about an important theorem called the remainder theorem. So the remainder theorem basically says that if you have a polynomial f of x and you divide it by x minus k, then the remainder is always going to be the function value at k, the function value that you get by plugging in k. So notice synthetic division is kind of made for this because we can divide by x minus k here, right? So, for instance, if we want to use the remainder theorem to evaluate this when x equals -2, we know, and then we can check our answer afterwards just to make sure. Here, we know that, basically, we know that f of x, that this function value with -2, f of -2 should be whatever we get when we do the division out, okay? Namely, it should be our remainder from doing the division of 3, 8, 5, -7, divided by x when x is equal to -2. Well, that would be x minus -2, but that -2 is going to be the 0 for that, in other words, okay? So, now we just do our synthetic division. 3 comes down, 3 times -2 is -6. Add, multiply, add, multiply, add. So f of -2 should equal -9. But let's just check that to make sure. If we plug -2 into here, we have that would be 3 times -2 cubed plus 8 times -2 squared plus 5 times -2 minus 7. Evaluating that out, -2 cubed is -8 times 3 is -24. Plus 8 times 4 is 32, minus 10, minus 7. So that gives me -24 plus 32 is +8, minus 7, +8 minus 10 is +8 minus 10 is -2, minus 7 is -9. And that's exactly what we got before. Now it's time for you to try an example. Use the remainder theorem to find each of the following function values given this. I'm going to go, and then I also want you to check your answer. I'm going to go through and reveal the answers one at a time so that you can kind of go through these. So the answer to the first one is 1, 2, 3. So here we get out, when we do our synthetic division, we get 1 out, and indeed when we plug back in, we get 1 out. For part B, we have 1, 2, 3. Here we see that doing the division gives us 396, and here we have doing the plugging in also gives us 396, so it works. For C, here we have that -13/2 is our remainder, and indeed -13/2 is what we get when we plug in. And finally, for the last one, 1, 2, 3, we get -17 as our remainder, and plugging in again, we get -17. For more practice in the working with the remainder theorem, be sure to look at page 142 and 143 of the textbook, and numbers 5 and 45 through 54. In our next video, we'll finish talking about all this division stuff with the factor theorem, which is kind of our big point.